who he was.
Yeah.
And then I'm like, okay, then I became amused by his, and he was very funny. All right. So let me give you all back your state test E stuff.
Oh, I did say that. See, nobody obviously supposed to answer. Oh my God. Yeah, I got an 8 out of 10. Because our whole house was like, you can tell that we're not. I think he did some weird, so much trash in our class. Yes. Not any math that I'm aware of. Ooh. They're so bad. Didn't you just get it? Okay.
So process 2 together. I don't know. And I can't like drive it this weekend.
Yeah, that's not.
And like that was because my car has good seating too. It has like 6 years.
A lot of E's, they were all wrong.
Okay, why did I get 2 of the bonuses right?
No, it's going to be that they have to stay quiet during studying, because it's the remainder of April, I want to see if they can do it.
I don't think they can. I think that they will ask me 5 minutes.
But I answered.
I'll tell them that next year.
2, 3, 4. I got 6 right, but I answered all.
Anderson coming to 806 class today.
Uh-oh.
807.
807A.
I don't.
Maybe it's 810.
Is that his truck? Maybe?
He has a truck.
I think he might be
It's like
having car
an
problems
old
because he's been
small
asking me for rides places.
Oh yeah.
Like this, right?
Understand that. Piece of crap.
I got 2 phones right.
You got to
How many did you write?
phone off.
I got 90.
Yeah, that's fine. Because I got an 8.
Probably run forever.
Countdown to the 40s.
I did worse than this. I like when I answer.
So is that
You should.
the end of the last exam or the end of the?
Well,
That's the end of first period.
Worse.
So first period
do
exam
you get a point if you don't?
will be 10 o'clock on that for Thursday. So I think that's 10 o'clock on that Thursday, first period exam. So y'all all be in here to see the
Oh
fireworks.
my gosh, I've always.
Did I ever tell you that story?
Wait, does it actually do something?
Oh, you like sprayed yourself with the.
Yes.
the can.
What?
Like I was in class, if you haven't heard this, I was in class and somebody goes, "What happens when it hits all zeros?" And I said, "Oh man, it makes this crazy." And this girl goes, "No, it doesn't. My aunt has one of those. It just doesn't do anything." I'm like, "Well, your aunt's got a crappy one." And of course it doesn't do anything. So I was like, I'll show her. So I bought an air horn. And I was like, so I was ready. And she was going to be in that class when it went to all zeros. So I had it under my desk and it was like, class was like 10, 9, and they were counting down and I was just, man. So I was just ready to sound it off. Well, I didn't know you had to hold an air horn upright. So I had it like under the desk with the sound thing, you know, the flute, whatever that makes all the noise pointing up. And it was right there, and it's like 2, 1. It hit 0, and I pressed it, and it's like a fire extinguisher if you don't hold it right. And it shoots this plume of white smoke like up in my face, in my glasses, and I'm like, "You got to be kidding me!" And people are like, "What just happened?" I had no idea I was holding an air horn, and I was like, "You got to be kidding me!" I had tested it out in the parking lot, and then after they left, I tested it again, and it worked. So the next semester, I was like, "I'm going to do this again." I still didn't figure out to read the label that says hold it upright. It did it again to me. At that point, I read the label, but whatever. I bet she was like, it doesn't do anything. But no, it doesn't do anything. It just hits zeros and it's very anticlimactic. But I should get another air horn. All right, state test E. We went through the evens and we haven't talked about the odds or the evens yet. So I will run through these answers or the questions with you again. I did not have the printer on the right setting, so just ignore the stuff on the right. But if you have your test and you want to just follow with me real quickly without looking yourself, here you go. So 1, this is state test E. 1 is D, 2 is A, 3 is A, 4 is B, 5 is B, 6 is B, 7 is C, 8 is B, 9 is D, 10 is C, 11 is C, 12 is A, 13 is A, 14 is D, 15 is A, 16 is A, 17 is E, 18 was B. That was kind of a lot of work for me, but doable. 19 was C, 20 was D, 21 was B, 22 is A, 23 was B, another kind of long problem, at least the way I did it. 24 was A, 25 was C, 26 was B, 27 was D. And I don't know if you guys even know those formulas, like the number of diagonals and the number of sides of interior angles, all this stuff. But we normally would learn those in our summer reading packet, but we didn't do that. So I don't even know if y'all know any of those. Maybe you learned them in geometry, but whatever. It was easy if you had those formulas, pretty tough if you didn't. Sweet. 8-10 class. Nice.
Just pushing the limits.
Yes. Give up. 27 is D, 28 is B, 29 is B, 30 is A, 31 is C, 32 is C, 33 is B, 34 I kind of like, but that was B. And pretty easy if you think about ratios. 35 is A, 36 is A, 37 is D, 38 is C, 39 is B, which wasn't that bad either if you got it labeled right, but I made it a bonus because it's geometry-ish and people tend to hate that. 40 is D. Another one that was not too bad if you know your trig identities, but whatever. 41 is C, 42 is C, 43 is B, 44 is E, 45 is A, 46 is A, 47 I thought was tricky, that was D, 48 was A, 49 was B, and 50 was B. Another one that was a little tricky, but anyway, I liked most of these geometry questions because they didn't require me to know geometry. They just required me to be intuitive about my pre-cal and algebra 2. So I like that. Because if you have to memorize the formula, I'm out. I didn't learn again from the geometry master. So whatever. Questions on any of these? Let's take a look. We really only have one more day. Tomorrow we're going to fill out a bunch of Scantrons and kind of get that knocked out. Remember our test, if you can be there at about 8, I really think if you can get in the building and down to the lunchroom by 8:40, 8:45, you'll be fine. I think Helmer's told his kids 8:40. But if you can get there 8:40, 8:45, find a seat. I think the way I'm going to do it is there are multicolored tests. There's like a white, a yellow, and a green. And I believe yours is white, although I'll double check that. And well, I was going to print them myself, and I bought all the colored paper, and then they sent me all the tests already copied. So I didn't have to copy anything. So they picked the color. So what'll happen is when you walk to the lunchroom, there will be all the tables in the lunchroom are going to be used, and I'm going to have like 2 to 3 people per table. Now there are a couple of tables that are super tiny. They'll just be one person. And then you know how when you walk through the middle of the lunchroom, there are those 6 seats on either side. Those will be all individuals. But what I'm going to do is I'm going to put like one color of each per table. If I can put 3, and then maybe just one color. So you'll just go and find your color and sit down, and then I'll walk around and hand everybody their Scantron sheet so you don't have to worry about bringing it and not having it. And then right at 9 o'clock, we'll just say go and we'll start. All right, so you won't be able to sit with your buddies at your table, but again, that's not really that necessary. But this way, there'll be no threat to cheat or whatever. And if you have to go to the bathroom, just raise your hand, get my attention, and you can go, although I'd rather you not. We can all hold it for 2 hours. But if it's an emergency, just go and come back. And you won't be able to have your phones. If you have your phone, I mean, you can have it, but make sure you turn it off. Make sure you put it on to take the vibrate off so it doesn't just bzz and annoy everybody around you, or whatever sound it makes when you get a text. And then you'll just either put it on the floor, or if you're at one of those center ones, you'll just put it up on the ledge. And that'll be it, and we'll be done right at 11. And if there's somebody who needs to take it early, is that what you're raising your hand? Oh, if there's somebody who needs to take it early, if you've talked to me already about that, I've got you approval on that. So you will show up, but you'll have to have already talked to me. And I think Helmer's room is about filled up. He has like a little early session. You have to be at his room at 7, which I know is early. So in his new, it's not his old room. His new room is in the brand new part of the building. I think it's 203. Like if you walk in the main front door and just if you walk in the brand new front door and take a right, it's that first door on the right. So you'll just go there right at 7. I won't be here, but I'll get here probably around 8:15. But if you get there right at 7, he'll bring you in there. He's going to start you at 7:15 sharp, and then you will be done at 9:15. Y'all with me?
What door is going to be on?
I'm gonna, since we're coming in the lunchroom. That's a good question.
It'd be possible to get some breakfast going in the lunchroom.
Yeah, we'll see what we can do, man. Steak and eggs good, man? Some donuts and
Are you giving us pencils?
Yeah, I'm gonna bring a ton of pencils, but I'd love it if you brought some, because I don't think I have 2 for everybody. I mean, I have got a lot of pencils sharpened up. Like I've got 2 bins full. So I've got a lot of them, but there's 115 of you. I don't have enough for 2 for everybody. I probably have enough for 1 if nobody brought one, and I'd like to have some backups. So yeah, if you can bring them, great, or a mechanical one, that's fine. It's not the AP test where you can't use those or something like that, or ACT. But and that's about it. So we'll do that Saturday morning, and that'll be the only tournament we have. And again, we'll need everybody to try to be your best, because the wild card I think we can beat everybody we've been usually testing against, but Mountain Brook's kind of the wild card there, because he doesn't really have a math team, but he has all these advanced classes, and every now and then a kid will be like, hey, I want to try, and he'll always take 2 or 3 kids to a tournament. But you never know, now that he's 6A, he might be a little bit more inspired to try to bring 4, because when you bring 2, you're not going to be competitive because you take the top 4 scores. But who knows, 6A is a little bit easier to compete, and this guy's the smartest teacher I've ever met. I mean, he's wicked smart, so he's my go-to when I don't know how to answer a question. I email him and he sends me back the result and makes me feel stupid. Yeah. Oh, yes.
Are we gonna have like a state issued proctor?
No, I'm your proctor. Helmer's is your proctor. And if you're testing early, Helmer's and Mr. Health, he's going to help us out in the morning. I don't know if you take physics, you know Mr. Health, but he'll be helping out a little bit with Helmer's at about the halfway point, so he can come over and help me roll out the test to all 110 of you or whatever that are not testing early.
So what
Coughing is
door?
not allowed.
Oh, so what door? My thought was that I would have the back door open, because I think my key works. Like I have a key that works in case the key card locks me out, because sometimes the key card doesn't work on Saturdays for some reason. So I don't know what we're gonna do if that didn't work. But anyway, my key actually opens one of the front doors.
Take it outside.
And
So front.
yeah, that would be awesome.
Nature.
Yeah. I think it's supposed to rain Saturday too. But yeah, so try this back door, and listen, be flexible. If you come to the back door and it's locked and not open, swing around and try the front door. But we can't put 100 cars in the front. So I'm just going to open up this back. And then I'm going to probably just, put something in there to leave it cracked and leave it open. So just make sure you leave it open and allow the next person to come in. All right. Okay. So anyway, questions on state test E. Let's take a look. I thought this was, of all the tests we've looked at, I thought it was the most doable. Now, me thinking it's doable doesn't mean that it's any different for you, but it meant I didn't have to discover as much. A lot of times I look at these tests and there's 10 problems I've never seen before, and I got to put on my, thinking cap or whatever. But on these, I knew what to do on almost every one going in, which is which is encouraging to me. I feel like it's a little bit more doable. But again, that doesn't mean that you've seen it, all that. Just means I have. But I kind of liked E. And E was 3 years ago, so 2018. So what do you got? Any questions? 48. So 48 asked to simplify that thing. All right, so this was infinite, right? And we've seen these infinite problems before, but normally they don't go 2, 3, 2, 3. Normally it's like 2, 2, 2, 2. So if you remember what to do on these, the first thing we always do is we say, well, let's just call this original fraction x. Give it a name. And then what we're going to do is once that's x, we're going to try to replace the infinite part with x. So we go and we circle what looks like the original problem. So since the original problem was 1 over 2 plus 1 over 3 plus, it had two parts, I'm going to circle where it goes 1 over 2 plus 1 over 3 plus. So that got me down not to this step or this step, but down to here. So if you look at that, doesn't that look like that if it goes forever? So I'm going to circle that and call that x and replace that whole part with x. Because if that is the same as the original and the original is x, that's x. So I replace that with x. Now I have an equation that's not infinite. And I can solve for x, which is the value of the original. So at this point I went, well, what if I could just cross multiply? So since this was a fraction, I took all of this and multiplied both sides by it, canceled all this out, left 1, and left me x times that. So at that point I distributed the x in, which put the x on the top. And then I didn't like that because I have a 3 plus x on the bottom. So I multiplied everything through by 3 plus x plus 3 or 3 plus x, which gave me that, that, and that. Canceled it all there. And at that point, I'm doing an algebra problem that didn't factor nicely. So I plugged in the quadratic formula and simplified and got it to here. Now, why isn't it plus or minus? And how do you determine what it is? Because x is equal to this expression. The expression can't be two things, right? I can't tell you to do something and then you end up with two answers. So it must be one of them. How do I know that it's the positive version and not the negative version? Because if you look at this, yeah, there's not even a negative in this problem. There's no way this problem could end up being a negative answer. And if it was negative, that would be like -3 minus about a 4. That's like -7 over 2. That's like -3.5. This can't be equal to -3.5. There's not even a negative in there. So it must be the -3 plus 4-ish, which leaves me about 1/2, kind of, or a little bit, kind of close to 1/2. So this whole expression's about a half, but I write it like that. What else? Any problem on here, even or odd? 12. So 12 said, seems like I remember them wording this funny. Where is my... Somehow I lost it. Oh, there it is. 12. Okay, so number 12 says this expression right here is equal to that. So I just made an equation that equals that, and it said find ABC. Well, this is like a partial fraction decomposition, but they made it a little tricky because this right here is not factored, so it's not completely obvious that that's equal to that. But it probably is. I mean, when have you seen problems with a and a bx plus c? You remember doing that partial fraction stuff. So I just multiplied that together just to double check, and sure enough, it was equal to that. So basically, I need to get rid of all my denominators. So I set a big fraction the left side, that side equal to that side, and I multiplied everything by x plus 2 and x squared plus 5, which canceled all of that out and left me, you can see it, I multiplied both sides by x plus 2 and x squared plus 5. It canceled all of that denominator out and left me this. And then here it canceled out the x plus 2 and left me that. And here it canceled out the x squared plus 5 and left me that. And at that point, you remember what we do? We pick cleverly chosen x's to help myself out. So, and again, I have to solve for a, b, and c. So I looked at this and went, oh, if x equals a -2, that'll cancel all of that out. Y'all with me? That'll cancel all of that out and leave me just the a term. So I plugged a -2 in for x and got 20 plus 4 plus 3, which is 27. And then -2 in here cancels all of that and leaves me 9a, so a is 3. And once I knew a was 3, I plugged a 3 in there. Now at this point, I don't have any nice numbers anymore that are going to help me, right? Because I can't make, I guess I can put 0 in there. 0 helped me a little bit. So when I plug 0 in there, that is going to make the math a little bit more simple and get rid of the b term. So when I plug this, and again, I'm just eyeballing this to see what numbers might be good. You can pick any number you want, but I'm trying to get rid of one of the variables so I can solve for the other one. When I plug a 0 in there, I got 3 on the left. Right here, I got 5 times 3 was 15. And right here, the b went away and the x went away, and I got 2c. So I moved the 15 over, divided by 2, and got -6. Now I know c is -6. And at this point, the only letter left is b. So I can pick any number I want. I just like them small. So I picked 1, and I plugged the 1 in there, and I got that expression, which gave me b is 2, and then I just multiplied it. But remember, all this is saying is it doesn't matter what x is. So you can pick any value for x you want. If I picked x equals 3 and plugged it in, that still works. It's just not going to get rid of one of the other letters, and you're going to end up with a system. You'll still have an a and a b left, or an a and a c left. And then you could solve your system if you want. But if you pick cleverly chosen x's that eliminate one of the a's, b's, or c's, or both, then you can solve for the other variables a little bit more easily. So anyway, but that kind of goes to that partial fraction decomposition thing that we did, except you didn't even have to do this, right? Normally they'll give you this and say, do a partial fraction decomposition. So you factor it, like you factor this bottom part into that, and you go, okay, this is going to be a denominator. This is going to be a denominator. Since that's quadratic, that's linear. Since that's linear, that's constant, right? And then you solve for the a and the b and the c that would work there, doing this process. But they just made it a little bit easier and gave you it already decomposed, I guess. You just had to find the ABC. What else? And again, you'll use this in calculus to integrate, because that's too hard to integrate. But these you can integrate. Well, normally you can. The problems they give you would be made so that you could. But this is a process you'll use in BC next year if you're taking BC. You'll need to remember this. He might go over it, might not, I don't know, but I teach it so that he doesn't have to focus on it a lot, and you'll learn that. In AB, we don't have problems that ugly to integrate. So, what else?
18.
18. So 18 is an ugly-ish trig identity. So it says find the sum of the solutions to this equation. So I looked at that and I went, well, if it's an equation, two things I don't like about it. One, it's got denominators. Y'all with me? A lot of y'all, man, I'm looking at bricks and stuff. Listen, lock in, these are problems that we can get. Who got this problem, by the way? This trig identity. Just a couple of y'all, like this is something, it's not easy, but it's something that we all can do. There are not really ugly identities in here. It's just persistence and having a vision, okay? And you don't even have to have an awesome vision. I think you'll see it. So on 18, the first thing I thought was, I don't want a denominator. So I'm going to multiply through by whatever will help me get rid of this denominator. And the denominator was cosine x and 1 plus sine x. So I multiplied the left by cosine x and 1 plus sine x. Cosine x cancels, and now I have two of those. I multiplied that by cosine x, 1 plus sine x. The 1 plus sine x cancels, and I had two of those. and then I multiply that by cosine x1 plus sine x, and nothing canceled. At this point, I multiplied everything out. So I FOILed that, brought that down, and then distributed that, and here I am. Now that enough would have been a decent identity to start you with, but you had to do a little algebra. But notice I haven't done any trig yet. I just got rid of my denominators. Now at this point, I'm going to pull out an identity or two. What's sine squared plus cosine squared? 1, so I placed it with a 1. Still, not any brutal identity yet, and that left me this. Now at this point, I brought everything over to the left side, and I got 2 sine x plus 2 minus 4 cosine x minus 4 sine x cosine x. And I had a 4-term polynomial. So that my only hope at this point is either to group the first two and the last two, or maybe if that doesn't work and help me, maybe I switch the order of the middle and then try grouping. It could be 3 and then 1. We talked about that kind of factoring, but most of the time it's not with these ladies that write these tests. So I grouped the first two and the last two, and I said, can I factor anything out of this? A 2. Can I factor anything out of this? A -4 and a cosine. And when I did this, there's my sine x plus 1. So then I factored out a sine x plus 1, and I was left with 2 minus 4 cosine x. Now at this point, I factored it. All I got to do is set each factor equal to 0. So I set that equal to 0 and subtracted the 1. I set that equal to 0 and subtracted the 2 and divided by -4. And all I have to do now is go to my unit circle and ask myself, what angles would the sine of that angle be -1? Well, where is sine -1? 270, but I can't use degrees because this problem said what? 18 said in radians, right? So in radians, I look at that and I go, well, 3 pi over 2, right? And then, so I wrote that down initially. And then I said, where is cosine of 1/2? Where do I go x 1/2? Over a little pi over 3 or over a little, which would be what? 5 pi over 3. So I wrote those down. Now, why didn't I add all 3 of them together? That's undefined. Why is that undefined? Because in the original problem, cosine at 3 pi over 2 is what? It's 0. So I can't use that because that gave me 0 in the denominator right there. And a lot of people wouldn't have checked that, even if they got that far. You got to be careful. Normally, cosine doesn't need to be checked because there's no domain issue, right? If I had started you out right here with that, there's no denominator. So any answer is going to work. Sine and cosine don't have asymptotes. You're fine. But because I started you here, I can't have anything where cosine is 0. And also, what is sine at 3 pi over 2? -1. -1 plus 1 is 0. So in both of these, it messed you up, and you had to throw that out. So all I have left are those 2 answers. Now, that's a lot of a problem. I think that's why didn't I put bonus by that one? Because there's a lot going on in that with 4-term polynomial factoring and algebra and a little bit of trig identity, but it wasn't as much trig identity as you might think. But you just had to trust that, hey, I know enough. I can get there. And I think you can. It's just a little daunting when you first look at it. What else?
You do 16.
Yep. 16. Okay, 16. Listen, you don't have any training for these. You just need to know that. There's nothing that I've shown you that really is going to help you with these kind of problems except being creative. So I think. Now, you might see something go, well, I did this. And I'm like, oh, that's genius. But at this point for me, I was like, man, for me to find f of 13, which is what it's asking, I'm going to need to know this a and b value so that I have an equation that I actually can do something with. All right. So I thought, okay, for me to find this a and b, I've got to link these 2 equations together to make them make sense because it's the same function, but it's f of 2 different things. So is there a value for n that you could plug in here so that you could make this like maybe f of 10 and this f of 10 so that I'll have the same thing and I can make a comparison? So I looked at this and I thought, well, what if n was, what did I use? And again, I'm just eyeballing this. I said, what if I could try to make both of these things 8? Like for instance, right here, if I let n equal 2, right there, then I get f of 4 plus 4, which would be f of 8, right? And by plugging a 2 in, that gives me 2a plus 2. And if I let n equal 1 over here, what do I get? F of 8. And then I would get f of 8 equals 3 minus b. So what does that tell you here? That equals that. And I have an equation. So that would have given me 2a plus 2 equals 3 minus b. Now, is there another number that you could see that I could pick values for n and make those match? Don't see anything? I went with, you said 9?
5.
Oh, 5? Yeah, if I put n equals 1 here, that gives me f of 5, and that would give me a plus 2. And if I put 2 there, that gives me f of 5, which gives me 6 minus b. And what do you learn from this? If both of them are f of 5, a plus 2 equals 6 minus b. And now you have a 2-variable system. And once I find a and b, literally that's all I did. Once I found this 2-variable system, I solved to get a and b. And once I know a and b, just go back to one of the functions. And I'm looking for f of 13. So if a is, what was f of 13? Which one did I use? So right here, I used the, I used this one right here. And I let a was -3. So I said for f of 13, if n was 3, that gives me 13, right? So I just plugged a 3 in for n, took the a value that I just found, plugged that in there, and that gave me f of 13 was -7. So there might be other ways to do it, but again, that doesn't, I know a lot of people see that problem and they go, ugh, I'm out. But these problems are ones where if you just eyeball them and play around with the functions a little bit, you can get somewhere, but you're usually trying to just make them make sense. Do a little observation. But again, I don't know how I fit this. I could put it in the function chapter, but it really, all these problems they use with these weird functions, they're all a little bit different. It's not like I can categorically teach everything. It's really more of just intuition and playing around and not assuming the position, but not a lot of ease to it. You can see there's a lot of liquid paper on my page, so I probably picked the wrong path a couple times first. What else? Anybody get that? What else, guys?
Six.
Sorry?
6.
6. So number 6. Now, number 6 is something I really do think we can get. All right, number 6 says, find the number of solutions to that system. So I looked at this system, and it has y's, absolute value of x's, and x's. So I thought, well, it is a system. Why don't I just solve for y in this one, which gives me 3 minus an absolute value of x, and plug it in for y here. And at least I'll have it in terms of x. All right, so that's what I did. I solved for y, and then plugged that in for the y right there. And then I distributed it. Now, what is the absolute value of x squared? It's just x squared, right? Well, that's nice because I got rid of one of the absolute values right here because I don't need absolute value to make it positive if I have an even power on. So that cleaned it up a little bit, but I still have this 3 root x right here. So when I saw root x, what do you know about absolute value? We've been talking about it since 10th grade. Sometimes it's positive, sometimes it's negative. So I wrote this statement out with a positive x, which gives me that. And then I wrote it out with a negative x, which gives me that. So I just have 2 equations. So I just need to solve those 2 equations. So when I solved this one, I factored it out. This did not factor, unfortunately. Over here, I factored out an x. This did not factor either. So what I did is I said, well, this x is 0 gives me a y of 3, because I went back and plugged it in the original. But this one to solve, I'm going to need to use the quadratic formula. So when I plugged it in the quadratic formula, I saw 1 minus 12. Well, what does that mean? It's imaginary, so I tossed it. Okay? And then over here, I plugged the values for this into the quadratic formula, and I got 1 plus root 13 and 1 minus root 13. And the 1, and then what did I do from there? So there's one real solution. This is 2 real solutions, but the negative one, the positive one didn't work. This is saying when a check, only that works. So I guess that I just checked that answer. Let me see the test question again, number 6. Find the number of solutions. It says real, so that's why I threw out the imaginaries. So I guess I just plugged those in. I guess I plugged them in, and one of them worked and one of them didn't work, of those 2, when I plugged them back into the original, which couldn't have been pleasant.
Is it because the absolute value, it's 3 minus the absolute value of x? So it would like be too big? Is that what, well, no.
Let's just look at it. So y plus something equals 3. If x was 1 plus root 13 over 2, that is already positive, right? So that is irrelevant. So I could subtract this from the other side to over to this, find a common denominator, and I would get y equals 7 plus root 13 over 2. It would go with that. And I guess once I did that, I went and plugged it in. Oh, so if I take this and then plug it into the other equation just to check it is this. So tell me why I don't even have to check this. X is positive, right? If x is positive and y is positive, when I multiply them, it's more positive, right? Still positive. And if I have a positive cubed, it's positive, and 2 positives added together can't be 0. So they don't work in the other one. So that's pretty annoying. I got to be honest with you, I might have even missed this. In fact, I see a lot of liquid paper. I might have looked at this and said 1, 2, that one is 3. I might have said 3 solutions and missed this. But and I probably did, because that's what that liquid paper is. But when you go back and check them, it's kind of sneaky. One of them actually doesn't work. Anyway, kind of dirty. But it's not always dirty. And if you just remember that sometimes it's positive, sometimes it's negative, you can solve systems like this. I mean, you can do it. There might have been a better way to do it from the start, but that's what I did. What else you got?
34.
34. Okay, I'm glad you asked about this. So 34, when I first saw it, literally, the first thing that I thought was, ugh, freaking geometry. That's literally what I thought. And then I went, okay, let me just give it a shot. And then I realized it was one of the easier questions on the test and kind of creative. So here's what I did. All right. So I kind of drew the picture to help myself. And none of this was labeled. All that was labeled in your picture was, this has a radius of x, this has a radius of 3, and this has a radius of 2. And then you had this angle or these 2 lines drawn. But wait, anytime you have a radius, what does a radius make with a tangent line? Makes a right angle, right? So all of these make right angles with the tangent line, which makes all of these triangles what? Similar. And if you have similar triangles, you can do proportions. So they already said that this was x, this was 3 and this was 2. Well, I need to know something about these lengths, and I don't know anything about them. But wait, I do know something about these lengths. I know that this is x from here to here. This is 3 each way, right? This is 2 each way. And the only thing I'm missing is this length, so I just called it y. I don't know that it's 8 yet. I just called it y. So what could I use for my proportions? Couldn't I say short leg over hypotenuse, 2 plus y, equals short leg, 3, over hypotenuse, 7 plus y? Couldn't I do that and solve? And when I do, I get y equals 8. So I did that. Now I know this. And once I know that, can't I say short leg over hypotenuse, which now you know is 10, I might have used a different one, whatever, equals short leg x over hypotenuse, which now you know is what? 6 and 4 is 18 plus x. And again, you can cross multiply. And when you cross multiply that last one, yeah, I use 3 over 15, but it doesn't matter. 3 over 15, 2 over 10, they're both 1/5, right? When you cross multiply there, you get x is 4.5. So it really was an ugly looking question. Anybody get that? Nobody? Who assumed the position? Everybody? Anybody try to play around with it?
4 looked nice.
Do what?
4 looked nice.
4 was an answer?
It
You
was.
were feeling 4?
I just,
Yeah.
It was one of those, it's like.
It would have been poetic had it been 4, right? Yeah.
Invading me to think it's more complicated.
I'm
than
feeling
that.
4, yeah. Yeah, don't feel 4. But yeah, be a little creative on these. This is not like old school Vestavia where you got to know every obscure little formula and you got the flagpole over here and a small one over here and you got these diagonals and all that weird stuff where you had to memorize formulas. You can usually navigate your way through these. Like for instance, the star problem. Do you remember that one? The one that had the star inscribed? You remember this 41? Like this is something where you don't have to remember a ton of math. Like what did they tell you on 41? We're struggling today. Where? Oh, 41. So 41, because this, I looked at this and I was like, ugh, I don't know this stuff. I assumed initially that this was going to really make me struggle. So they said, okay, it says, blah, 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 lie on the circle, 0 is the center, AD and CE. So here's AD and there's CE. It says they both go through the center. So those are what? AD and CE. Those are diameters. It says BEC. So B to E to C. It said that has a measure of 28. And if BEC has a 28, what do you know about that? Do you remember? That's the geometry thing you have to memorize. It's double. So remember, if you have something going through the center, then that angle matches that angle. But if you have something coming to the edge, then that arc length or whatever is double that. So I know that this must be 56. Okay? Then it tells you that, and I don't know if you remember that, it says ADB has 37. So if ADB is 37, what do you know about this? 74. And if I know that that's 74 and that's 56, then what do you know? Shrink this down a little bit. If that's 74 right here, right there, and that's 56, and this is a diameter, what do you know about that? This has got to be what?
180.
180? So that must be 180 minus 74 minus 56. This is 50. And you are asked to find this, right? So if that's 50, then this must be 25. Are you with me? And wasn't that the question?
It's ACE. That's what we're finding.
It would be the same though.
Yeah,
Still very
because
nice.
it's still on the diagonal, or the diameter.
Oh, right. So if that's, yeah, if AO and CO are both radii, then VAC and ACE would be equal. So anyway, y'all track with me? Yeah.
On the one, you go back to the one before that,
40?
you want the angle in the circle.
I'm sorry, which one?
The one with the angle in the circle.
Oh, right. What about it?
I just did a ratio.
That's all I did.
So like, I did the first one.
I don't remember which problem it was. Do you remember what problem it was?
I think what the thing had 120.
Oh.
I had to get the first one to get the second one. You said times 303 and I said times 303.
You did what?
So like get from 2 to 3. Use 3 times 303. So I did 3.
Why'd you do 3 times 3?
Because that's what you do get from 2 to 3. Because the ratio from that one to that one. But,
Oh.
is that a coincidence or is that like?
I don't, just what, after you say that, it kind of feels like that makes sense. It feels like it does, but I would have to play around with it to see.
Maybe I'll get my own rule.
Yeah, not from geometry, because I probably won't play around with it. No, that feels all right. Yeah.